So the ellipse formula is x squared over a squared plus y squared over b squared equals 1, where a and b are positive constants. But why does that formula make sense? Why should that make any shape like this? So usually the way this derivation starts is it starts with 2 points, ironically, that are labeled C0 and negative C0, and C doesn't even show up in that equation. So this distance is C, right? And that distance is C also. But then where are the A and the B? Well, to start with, let's think about this triangle. This hypotenuse is going to be length A, this is going to be length B, and this is going to be C. So you know that A squared equals B squared plus C squared, right? And so essentially, you're going to define the ellipse by this length, D1, plus this length, D2, is going to be a constant, usually 2A. And so if you have that, certainly if this length is A and that length is A, life is grand. And so that puts this point, what is that point, by the way? That point is 0B. That, by the way, is a co-vertex. This is a co-vertex also. 0, negative B, right, up and down from the origin. Co-vertex. But then somehow, what about these points? These points are rather important. We call them vertices, where the singular, this is a vertex. This is a vertex. Where should you expect them to be if these dimensions, maybe you say, I believe that's a right triangle. Maybe I even believe that that's up B, so that should be at the point 0B. Why on earth should this be at the point 0A? Oops, should be the x coordinate that goes A, right? A, 0. And then why should this be 0, negative? Oh, I'm doing it again. 0 is the y coordinate, and negative A is the x coordinate. Why on earth should that be the case? Well, so any two distances, this distance plus that distance, should add to 2A. So let's think about what would happen if you had this distance here, that's the distance from this focus to that point, plus that distance there, okay? So, I don't know, maybe we'll call this distance here x, right? So what do you really have there? This distance down here is C plus x. C plus x. And the distance of this one is just x. And that's all supposed to add up. Those two distances are supposed to add up to 2A. Well, what does that really tell you? I mean, I guess I have 2 C's, 2 X's. So 2C plus 2X equals 2A. Or we could just simplify that by C plus X equals A. Well, wait a second. What's that mean? C plus X is A. That means that point is going to be A. You can sort of see by symmetry this should be a distance of A in the negative direction, so that's negative A. Okay, so why should it make sense? Well, think about something that looks sort of circular, like, right, a circle would be x squared plus y squared equals r squared. If you wanted to get a 1 on one side, you could divide, and you could have x squared over r squared plus y squared over r squared. Well, but that's where the distance is the same in every direction from the center, right? Here the distance isn't the same in the center. Well, let's try and make this make sense here, okay? Well, you need an equation where a comma 0 satisfies the equation. Well, what about a comma 0? Well, that's going to be a squared over a squared plus 0, right? Because this is y squared equals 1. Well, that kind of makes sense. Does it matter whether that's positive or negative? Of course not. If you square it, it's still going to be very 1. And so it makes sense because it goes through the vertices, and it also goes through the covertices. So 0, B for 1, or we could put negative b for the other. Well, let's think about what that does to the equation. 0 is this term, plus, if y is b squared over b squared equals 1. So this somehow satisfies the equation, and really, I sort of think about these points as being the points that really motivate the whole rest of the piece, right? This is uniquely designed, so A0 and 0b will both satisfy the equation. Okay, one last piece that just makes a lot of sense to me. Take a piece of string and just put 2 thumbtacks in the string. And then, so what that does is it ensures that the length of the string between the two thumbtacks is constant. What happens if you just stretch that out and you just let it ride with a pencil, okay? What shape do you get? Come on now. Can you see that what you're getting is you're getting an ellipse? Well, there's no reason it shouldn't be stretched downward. And in fact, what you get is basically a perfect ellipse just by following the definition. Look, the distance from my pencil to these 2 points adds to a constant.